Hello and welcome to this video. This is part 2 of the videos for section 7.4. Those are the rules of replacement part 2. So in the first part I explained the last set of rules, the remaining rules, and what I'm going to do now is work some problems where we apply some of those rules. We're not going to apply all of them, but we're going to apply some of them in order to do these proofs here. Numbers 1 and 2 here, the first two here, actually they're not numbered, but the first two here are from your homework for section 7.4. So just be warned that those are from the homework. If you want to try the homework on your own and then come back and check your answers and watch the video later, then that's fine. Remember that what we're doing is we're applying the remaining rules, and we'll come back and apply some of the other rules as well, some of those from section 7.3. So here we have all of the rules of replacement, and we're going to be applying some of the rules that we learned in our last video. And by the way, we're also going to be applying the first 8 rules of implication. So we're basically working with all the rules now. We just have to see which ones are appropriate to get us to solve, to prove whatever it is we're trying to prove. And so we'll just work on it by application. So our first proof here, again, remember that the first parts are the premises. So the first premise is if S and K then R. Our second premise is K, and then what we're trying to prove is if S then R. I'm going to put it over here on the right hand side. In MindTap, you usually have it after the last premise that they give you. So if it's 2 premises or 3 premises, they usually put it there, which is a little confusing, but it does say conclusion there, and that's what we're trying to prove. We're trying to prove that conclusion. I'm going to put it on the top right over here. Okay, so the first thing that we should notice is that this form here, if S and K then R, does look somewhat familiar in terms of one of the new rules from our last video, and that's the exportation here, right? I'm going to highlight it over here. Notice that with exportation we have if P and Q then R, and then we have that is equivalent. P is in first position in both places. It's in first position here in that conjunction, which is an antecedent. That whole conjunction is an antecedent, and it's in first place there. So it may be a good idea for us to put the K in first position, because notice that we also have a K over here, right? And then we do want if S then R. So we might be able to do something if we change the position of that K and put it in first position, because we do have a K by itself here. Maybe we could eventually use Modus Ponens to get what we want. Let's just try that. And by the way, it's good to try just anything as long as it is something that you can legitimately do with the application of one of the rules. Then it's fine to try whatever you want as long as you're applying the rules correctly. Okay, well, if we do put that K in first position, then we have as our antecedent now we have K and S, right? Are we allowed to do that, by the way? Of course we are. After all, I'm doing it, right? What rule allows us to do that? Well, remember that there's a rule where you could switch the order of conjunctions and disjunctions, and that rule is commutativity, right? Remember, this is commutativity here, and with commutativity we can change that part. Remember, we're applying it only to a part of the first premise, or that first proposition, and so that is why it's a rule of replacement. Remember, replacement means we could do it to parts. Another way to say it is substitutions, right? We could substitute that part with K and S instead of S and K. The rest of that proposition stays the same. So the horseshoe and the R stay the same. Again, only one little part was affected by the application of that rule. So our justification for doing that, again, remember, is commutativity, which is COM. We applied commutativity to line line 1, and so that allows us to do that. Okay, now we have a form again that looks like this form here that I was talking about earlier. It looks like this is an application of exportation, right? Okay, so the question is, now that we have that K there in first position, if K and S then R, what are we going to get when we apply exportation? Well, remember, we get the form here, if P then, if Q then R. Okay, well then that means that basically our K is our P, our S is our Q, right? I'm just basically showing you what variable corresponds to what letter here, and our R is our R, right? Except here it's with capital letter. Remember, it represents a specific proposition or specific statement. Okay, well, that means that if we apply exportation there, then we're going to get something that looks like this: if K, then if S, then R, right? And that's, again, that's a straightforward application of exportation to line 3, right? EXP to line 3. Okay, so now it looks like we could use that to get the if S then R. How do I know that? Well, notice that we have K by itself over here in line 2, and we have it here as an antecedent. So it looks like we could apply modus ponens. Remember, modus ponens is if P then Q, P therefore Q. Our P here is our K. If P then Q, our Q is our if S then R, which is what we want to get out of there. And so, and then our P here again is the K, right? So basically, if we apply modus ponens to line 4, I'm going to move these down so it doesn't get confusing. If we apply modus ponens to lines 2 and 4, we get what we're trying to prove, right? Which is if S then R, and so that is cited as lines 2 and 4 MP. Okay, all right. So that's it. That's what we want to. That's what we're trying to prove. Again, I did it here in a Word kind of format. You could do it in pencil and paper. You could do however you want. But eventually, we're going to have to come back to MindTap, and we're going to have to see how this works out in MindTap. Okay, well, all we do is basically, input everything here into MindTap. Remember, the first thing we did is we switched the order of the K and the S. We have K in the first position, and then we have S. And so we have if K and S, then R. Remember, the horseshoe and the R stays the same. And so what we did there is commutativity on line 1, right? So that's fine. That it's telling us here that that is a correct move. So let's go ahead and do our second move, which is remember an application of exportation. There we have exportation to line 3. And so remember, when we apply exportation, we have if K, then if S, then R, right? And so that is a legitimate way of applying exportation to line 3. Okay, so now remember why we wanted to do that is so that we could get that if S then R by itself. And now notice that we applied modus ponens, right? We have the K and the K there. So if P then Q, P therefore Q, our K is our P there. So we can get if S then R, and we did so by applying modus ponens to lines 2 and 4. So that is it, and it tells us that it is correct. Okay, so that is number 1. Let's go on to number 2. There is number 2 there. And so I'm going to come back to the Word format. But again, it's the same thing. You could do it in pen or pencil or whatever. The reason I'm doing in the Word format is, by the way, because for your exam, your final exam, you will have to submit it in a Word format or a written format. So it's good to get used to doing this outside of MindTap. Again, it's the same thing. It's just we're doing it in different formats, right? Okay, so for our second one here, which is number 2 in the homework, we have if G then E as our first premise. We have if H then not E as our second premise. And what we're trying to prove is if G then not H. So the question is there something here? I'm going to highlight what we're trying to prove. Is there something here that we can do right away? It's always helpful to look at the conclusion, look at what we're trying to prove to see if that gives us a hint. Notice that there is a hint here. We have the not H, right, in what we're trying to prove. But in what we are given, we don't have a not H. So the question is there a way to get that to be a not H? And if we look at all the rules, there is a rule that allows us to switch the order of the antecedent and the consequent here, which will in fact make that a not H. So let's go back and look at the rules. This is the rule of transposition. Notice that with transposition, we have if P then Q is logically equivalent to if not Q then not P, right? So if we apply that to line 2, notice that we're going to have to switch the order of the antecedent and the consequent. The consequent is already a negation, and we cannot ignore that. We have to keep that the same. In fact, that's going to be a not E. And then remember that that H is now going to become a negation, right? Because we're switching the order. Oops, that's a mistake. We're switching the order of the antecedent and the consequent, and so that H does become a negation. But the not E is also going to become a negation. It already has a negation. We have to add another negation. That's because, remember, this is, if we look at the rule, our P here originally, right? And our Q is our not E. So that means that our Q is already a negation. It has to stay a negation here as well. The only difference is that we're adding this other negation because that's what the rule requires, right? We switch the order of the antecedent and the consequent, and we add negations to both. That means adding a negation to that already existing negation, which is an E. And so we get basically a double negation there, right? Not E. So our new premise here is if not E, then not H. The rule that we were able to do that by, remember, is transposition, which is T-R-A-N-S, trans. Now we go to line 4. Okay, well, notice that what we want is, again, if G then not H. We do have the not H here. We have the G over here, so it looks like this is kind of gearing us towards the hypothetical syllogism. Remember, the hypothetical syllogism is the case where we have if P then Q, P, therefore, if P then Q, let's go back to look at it. If P then Q, if Q then R, therefore, if P then R, right? There it is. So it looks like everything we're doing is kind of gearing us towards a hypothetical syllogism. The question is, the details here. How do we work that out in terms of the details? Well, notice that with the hypothetical syllogism, there's kind of a middle term here, which is the Q that connects them, right? The question is, do we have that here? Well, we do have not E here, and then we have E here. The question is, can we get this not E to become an E, so that then we do get that middle term, which in our hypothetical syllogism, that would be our Q, right? Can we get that middle term there? And the answer is, of course, yes. Remember that not E basically just means E, right? And the rule that justifies that is double negation, which is one of the rules that we did in section 7.3. So basically that means that line 3 can become if E then not H, and the rule that applies there is DN, which is double negation. Again, notice that it's a rule that is only applying to a part. It's only applying to that antecedent. and that's fine, because remember, the rules for replacement work in such a way that they can only be applied, or they can be applied to only parts. They can be applied to whole propositions as well, but that's the interesting thing about them, is that we could just take parts and replace them. That's why they're called replacement. Also substitution, and in this case we're replacing that not E with the E, and double negation allows us to do that. Okay, so now we have everything we need in order to set everything up for the hypothetical syllogism. If P then Q is basically our if G then E, right? And then our if Q then R is our if E then H, right? And so remember, hypothetical syllogism, if P then Q, if Q then R, that gives us if P then R. Well, our P here, again, remember, that's our G. So for line 5, we write if G, then not H, right? Our R here, from the form, our R here is the not H, right? Our R is that one there. And so we can get if P then R, which in this case is our if G then not H. And that is what we were trying to prove. So we have completed the proof. We have to cite that very last step, which remember is lines 1 and 4, HS for hypothetical syllogism. Okay, so that's it for this one. Let's go back into MindTap and input this in. Again, this is just so that you are familiar with MindTap, and that's what you're working with, so that's what we need to do here. Okay, well, remember that our first step here was to do a transposition on line 2, so that we get not E, then not H, right? And so what we did there is we did a transposition on line 2, and that is fine. That works out fine. Now remember, we have to get rid of that the two tildes, and get if E then not H. And so remember that what allows us to do that is double negation on line 3, right? So that's DN on line 3, and that should be fine. That's a legitimate move. Okay, so now remember, our last step was to set up the hypothetical syllogism, and via the hypothetical syllogism, through the use of the hypothetical syllogism, we get what we want, which is our if G, then not H, right? That's what we were trying to prove. If G, then not H. And the rule that justified this is lines 1 and lines 4 via the rule hypothetical syllogism. And that's it. That completes our proof, which it does show us here that that's correct. Okay, so I'm going to do one more that's not in MindTap, and this is just extra practice so that you see more examples being worked out. The more examples that you see being worked out, the more helpful it is to you. This is the one I have here. This is a little bit harder, requires more steps, but again, the rules are the same. We're just and our procedures are the same. We're just basically applying those same procedures. So we're trying to prove if not P, then not U. All right, well, the question is, where do we start? Okay, well, notice that we want to get something that eventually, notice that our conclusion, what we're trying to prove, has the not U in it. And then if we look at our premises, the only way that we can get a not U out of there somehow is through there, right? The consequent there has the negation of U, right? The not U. So the question is, how do we get it out of there? Well, it looks like we're going to need not T by itself so that we could apply Modus Ponens eventually and get that out of there, right? So the question then is, how do we get the not T out of there? Okay, well, first of all, we don't even have a not T. We have a T, right? But is there a rule that allows us to make that T into a not T? And yes, remember the rule is basically transposition. Transposition allows us to switch the order of those. Here it is. Remember that it allows us to switch the order of those, and then both of them become negations, right? So if we apply transposition to line 2, remember that the not P has to stay a not P. It's just that we're adding another negation. Remember, if P then Q, our Q is our not P. And then we're going to have, if P then Q is equivalent to if not Q then not P. Well, our Q is already a not P, so we just have to add another negation. And so when we switch the order of the antecedent and the consequent, we are going to have if not P, then not T, right? So now we have, at least we have that, the negation of that T, which remember eventually we want, so that maybe we could use modus ponens and get that not U out of there. Remember, there's a reason why I'm doing this. There's a kind of... Alright, so I have to justify my line 4 here, and remember what I did there was basically just transposition on line 2, right? Okay, so now the question is, what can I do next? Okay, well, notice that we do have a P by itself here, and then we do have a not P here. Well, that should scream out double negation, right? Because remember, we could apply double negation to a part, that's just to that antecedent, and basically get that P by itself without the tildes. So if P, then the not T stays the same. Remember, we're applying it only to that part. And so what we've done there is we've gotten rid of those two tildes by double negation onto line 4, right? We'd applied double negation onto line 4. Okay, why did I want to do that? Well, notice now that we have if P then not T, and then we have P by itself, right? That should remind you of something. If P then Q, P therefore Q. That is modus ponens. Notice how often modus ponens comes up. It comes up quite a lot, so you definitely want to know your modus ponens and always look out to see where it might apply. It does come up a lot. So, okay, our if P then Q here is our if P then not T. We do have our P here, our uppercase P. Well, then from that we can get our not T. And so remember, the justification there is lines 3 and 5, modus ponens, right? We got that with lines 3 and 5 with modus ponens. Okay, so things are looking pretty good now. The question is, what next, right? What can we do next to basically keep going, right, and get that not U out of there somehow? Remember, what we're targeting is that not U, which is, it is disjoined. There's a disjunction there to that P. We'll figure that out later. For now, notice that we can get this whole consequent out of there, right? How do we know that? Well, again, modus ponens. There we go, modus ponens again. Our if P then Q is this whole thing. The antecedent is the P, which is the not T in this case. The consequent, or the Q, is this whole thing here. So we could basically get that out of there by modus ponens. If P then Q, P, our P is our not T here again. Therefore Q, which is our consequent there. So we could basically get that whole thing out of there. Let's get rid of that parentheses there. And the reason we could do that is lines 1 and 6, modus ponens, right? Okay, so now what? All right, well, notice that what we want to prove, it looks like we're getting closer. We have our not U here, and we have a P here. So in terms of the actual simple propositions, it looks like we have them. We just have a completely different operator here. Here we have a horseshoe, and here we have a wedge. The question is there a way that maybe this not U or P can be switched into I guess we have to switch it into a horseshoe, right? We have to make it into a conditional statement. Remember, these are conditional statements. Is there a rule that allows us to take a disjunction and make it into a conditional? That's the question here, because we do have a disjunction here in step 7. And so the question is there a rule that allows us to do that? That lets us go back and forth between a conditional and a disjunction. And the answer is, of course, yes. Let's go back and look at the rules. Notice that material implication is what we want, because with material implication, we can go back and forth, right? Notice that this is a conditional statement and then this is a disjunction. So the question is, what do we have now and what can we get? Okay, well, we basically have this here, this form here, not P or Q, right? Except we have it as our not U or P, right? So how do we make that into basically our if P then Q? Okay, well, basically that means that the not P or Q basically just becomes basically this means that in line 8 we're going to have, notice that the U stays where it is, because that's the P basically. But what happens here is that the it loses the tilde, right? And then that's a mistake there. Let me copy and paste the horseshoe. It loses the tilde, and then we switched the operators to a horseshoe. And so we're basically going to have if U then P, right? So all I've done there is our P is our Q, right? And our U is our P over here, right? I know this sounds confusing, but all I'm doing is I'm applying that rule. And so notice that if we switch, we basically get if U then P, we drop the negation, which is what happens here. The negation is dropped over here, and then we switch the operators from a wedge to a horseshoe. Okay, well, again, the rule that allows us to do this was we applied material implication, IMPL, to line 7, right? Material implication to line 7. Okay, are we getting close? Okay, well, in line 8 we now have if U then P. Notice what we have in what we're trying to prove. Notice that we have the antecedent and the consequent have switched place, and we have a negation now has been attached to both of them. So the question is there a rule where the antecedent and the consequent switch places and where we have negations attached to both of them? If we look at the rules, yes we do. It is right there. Transposition allows us to do that, right? So basically if P then Q is our if U then P, and so now we can basically add negations to both of them and switch the order of the antecedent and the consequent, and we have what we want to prove, right? So notice that is exactly what we want to prove. If not P, then not U. And so what I did is I applied the rule of transposition, which we did use over here earlier, right? We did do that earlier, except this is actually an easier application of transposition. For in line 9, it's actually an easier application of transposition. And so that's what we want to prove, right? If not P, then not U. Okay, so that's it. Notice again that what I've done is, I've taken the rules, I've looked to see what forms we have with these statements, and I've applied the rules to eventually get to a conclusion. And this is what you're going to be doing for